Alright, today in our notes we're going to take a look at transformations. We have three different transformations. We have translations or slides, reflections or flips, and rotations. So take a look at our translations or our slides. Basically what we have is these vectors. These vectors go from one shape to the next. And this vector is the same length all the way across. So each point gets translated to a new spot. And then basically what happens is it's like this shape just glides down those vectors to our new shape. So in this case we're taking a look at our original shape is going to be the black shape, and we're going to move to the white shape. Okay, so describing this translation, it's just a slide. It's just moving those values across. Okay, so moving each point to make this new triangle. Now, how do these x coordinates change? Well, my x values went from here over across. So it went right 3. What about our x values? So our x values went down 4. So all we're doing is moving it, in this case, moving it right 3 and down 4. Every point gets moved right 3, down 4. Now we can take a look at this mapping, okay? And this formula is what we have. So how does this work? So our original, okay, and this is just a translation, okay, and the 3, 4 is how we're moving, okay? So translation 3, 4. So original shape are XY points. Each point then gets translated. X, since we're going right 3, right is going to be positive. So X plus 3. And since we're moving down, Y moving down 4, so minus 4, and each point gets translated that way. So that's a translation. It's just moving the shape up, down, left, and right. Okay, so anything moving x coordinates to the left would be minus. Anything moving up would be y plus a number. Okay. So it all varies on how this movement is. Okay? So right is going to be positive, left is going to be negative, up is going to be positive, and down is going to be negative for my y values. Okay? And then we come up and we get to have this mapping, which then I can use for every single point to find the new image. So that's a translation. Again, it's just sliding this shape is basically what's happening. So shape doesn't change, it just slides along, and each point is slid along there to make new points and make that triangle move. Reflections. So we have two different reflections. We have reflection across the x-axis. Okay, so we're flipping it from the top down to the bottom. And then we also have a reflection, we can reflect it across the y-axis. So we're going to flip left to right in this case. So again, taking a look at our reflection across the x-axis, we're going to go from the black shape to the white shape down below. Okay? So take a look at our coordinates first. So if I want to match this coordinate up, so here's a coordinate, so I have 3, 5, another coordinate, so 5, 1. And the third coordinate on that first triangle is 3, 1. So there's my 3 coordinates. Again, when this thing flips over, now the easiest one to kind of see is this blue point. It's still up at the top of this triangle here. Okay, so the new blue point is 3, negative 5. My red point then gets flipped over, so here 5, negative 1. And then the new purple point, again reflected, and we get 3, negative 1. Alright, so again, so let's take a look at what happens on these points. So my original point was 3, 1. My new point, after the reflection, is 3, negative 1. The blue points then are 3, 5 for my original, and my reflected shape is 3, negative 5. And then the last is 5, 1 for my original, reflected, and I get 5, negative 1. So this is what we can come up with now with our mapping. So again, okay, we're going to come up with a rule here. So this is a reflection, okay? So a reflection in this case is going to be the x-axis. Again, we start out with x, y. And so what happens is, original was 3, 1. The new shape is 3, negative 1. Original 3, 5. New is 3, negative 5. And 5, 1 is the original. 5, negative 1 is the new. So the numbers stay the same. The difference is that y value is the opposite. So we start with x, y. When we reflect it, it's going to be x opposite y. Okay, again, I like the opposite because if it's in the bottom and it gets reflected across the x-axis, it's going to move to the positive side. So think about that as the opposite. Okay? So now let's take a look at the reflection across the y-axis. So now we're going to go from the black shape and we're going to go to the gray shape. Okay? So again, we have this original point 3, 5. And again, if marking it on this gray point now, so here's that same point on my gray shape, my translated reflected shape across that y-axis. It's going to be negative 3, 5. So the red point 5, 1 is the original, reflected, and now it's negative 5, 1. And the purple point is 3, 1. Gets reflected, negative 3, positive 1. So again, it's that same, the distance is going to be the same. We're just going straight across. So if I want to look at this, I can say 1, 2, 3. So from that point, that reflection point, 1, 2, 3, there's my new point. Okay? So when I look at this mapping now, again, it's a reflection. Now it's the y-axis. So again, we have our original xy that's given. To find the new points, the only thing that changes is now our x is opposite. So opposite x and y. And there's our mapping for reflection across the y-axis. So let's take a look at our last option here, rotation. So we have this rotation, and all our rotations are going to be around this point, origin, 0, 0. Okay? So all rotations are around that point. And I'm going to outline here again. Here's my original shape. And now I'm going to rotate that shape 90 degrees. So here I start, rotate 90 degrees, and there's my new shape. So there's my original was the red, rotated 90 degrees, and now I'm down here where this black shape is. So why is this a 90-degree rotation? Well, if I take a look at these points and I go from one point to the next, so let's take a look at our from the very tips here. So from this point to the rotation point, and then the rotation point to the new point, you can see this right here creates a 90-degree angle. Okay, so that's that 90-degree rotation. Okay, if I go back, let's say I rotate this shape now from here, my original, rotate it 180 degrees, so 90, 180. Now you can see that straight line. This line is straight. It's just going to go straight through, and any straight line is 180 degrees. Okay? And then the last rotation, so if I rotate 90 more, 180 plus 90 gives me a 270 rotation. And again, if I take this put one more line on here up to the point, and again it looks like a 90-degree angle here, which then means this rotation here is at 270. Okay, so we have a 90-degree rotation clockwise, 180-degree rotation, and 270-degree rotation clockwise. Okay, so let's take a look at those values now. Let me get rid of those lines. Okay, so there's our original shape. Okay, so again, we have our 90-degree rotation clockwise here. Right? So let's take a look at those values. So I'm going to put a point here, and we're going to find this value. So 2,4 is that purple point, and we're going to go on the other side of that shape, and we're going to go 4,2. So those are the values and the points we're going to look at how they move. So 90-degree rotation clockwise moves it all the way to here from my green point, which is now 2, -4. And the purple point is now here, which is now 4, -2. So again, original point 2, 4, move to 4, -2. Original green point was 4, 2, and again rotated around and is now 2, -4. So what happens? Well, what's my rule? So we have a rotation around the origin, okay, and in this case it's going to be 90 degrees. So we put a little 90 there. Original values are x and y, and we're going from 2, 4 to 4, -2. So what happens is this y value goes to the front. So now our y value is in the front, exactly the same, 4 and 4, and our x value moves to the back, but it's the opposite symbol, opposite sign, so -x. So y -x. So each point goes to original xy, and the new point is y -x, and that will give me a 90-degree rotation around that origin. Okay? So now let's take a look at our 180. So again, this was our 180 degree rotation. Again, we're going clockwise. So clockwise, moving around this direction. So again, keeping those same points. So to find those new points, here's my purple point, so -2, -4, and my green point then rotates around and is now -4, -2. So evaluating those points, we go from 2, 4 on the purple original to -2, -4. And then on the green points, we went from 4, 2 and rotated around, and now it's -4, -2. So again, just looking at those values, we can write this rule. Again, a rotation around the origin. This time it's 180 degrees. Original points x, y. So 2, 4 changed to -2, -4. So they just became the opposite values. So -x, -y, or opposite the x, opposite the y. So again, if it's positive, it's negative. If the original was negative, it becomes positive. So our last rotation then is the 270 degree rotation clockwise. So clockwise 270 puts us in that top left quadrant. So again, if we look at these points, so my red rotates around, my purple rotates around and is there, so this -4, 2. And then the green rotates around and is now -2, +4. So again, let's put these down so we can compare them. So we have 4, 2 is my original. It moves to -2, +4. And then on the purple side original was 2, 4. And that changes then to -4, +2. So again, now we can write this rule. So rotation around the origin, 270 degrees. Again, original points are x, y. It maps to now, so 4, 2 changed to -2, +4. So again, that y value moved to the front and became opposite, so opposite y. X value stayed the same and moved to the back, so opposite y and x. So there's my mapping. Now, if I go back to this shape, I can also rotate it the other direction. So if I take this original shape and rotate it now counterclockwise, right? Counterclockwise, it's going to go to the left. Okay. Clockwise is moving to the right. So again, if I rotate this now to the left, 90 degrees, now that image is in the same spot that 270 was. So a 90 degree clockwise is the same as a 270 degree counterclockwise. If I rotate that shape 180, you can see 180 clockwise and counterclockwise are the same. So 180 doesn't matter if it's clockwise or counterclockwise. And if I rotate that, then 270 and a 90 are the same. So 270 clockwise is the same then as a 90 degree counterclockwise. Okay, so 90 clockwise and 270 counterclockwise are the same rule. 180 is the same both directions, and a 270 clockwise and a 90 counterclockwise is the same rule. Okay, so make sure you hold on to this notes so you have these specific rules, especially with rotations. Those are the ones can kind of get tricky and harder to figure out. Okay, so you have those rules. Same with rotations, and the rules with reflections. Okay, and then the rules with translations. Again, the translation ones you're just adding or subtracting based on direction of movement. Okay, so that's our notes for translations. Next week we'll take a look at one more movement, and it's called dilation, and it's making the shape bigger or smaller. That's all I got for you. Have a great day.